5. This is the last section in chapter 7. We'll spend a few days on it, and then we'll test sometime next week or the beginning of the week after that over chapter 7, and then we'll get into our semester test review. So, we're factoring polynomials of the form x squared plus bx plus c, and we're going to deal with what we call difference of squares polynomials. So, past few days / weeks, we've factored out the GCF. We've factored by grouping, and that's pretty much all the factoring we've done so far, right? So today is going to be our last, the next few days will be our last section of factoring. And so I'll have you write all these steps down when we get to it. The polynomials that we factor today will follow these conditions. They'll have a degree of 2. We call those quadratics. The number of terms is 3, so they're trinomials. Except for the difference of squares. That's a different section. And the coefficient A of the squared term is 1. So our leading coefficient is 1 today. So all our polynomials today will follow these conditions. Okay. If I were you guys, I would write down this chart, this little T chart down in the bottom right. Whenever we're dealing with our polynomials, we're going to be creating this T chart. The C value is our constant from our polynomial. The b value comes from our polynomial as well. It's the term being multiplied by x. And I'll show you what we do with that t-chart when we get to it. But we will be using that for every example we do today pretty much. Any questions up to this point? All right. Like I said, the c and the b value both come from our polynomial. C is the constant. B is the number being multiplied by x. Can I move on? No?
Yeah. No.
We do need to move rather quickly. So I'll wait just a few more seconds and I'm going to go ahead and move on. Like I said, we got lots of notes today.
Alright, you're good.
We good? Write these steps down. These are the steps we're going to use to factor our polynomials today. So when we're factoring, we're going to have 2 sets of parentheses. Those are going to be our 2 factors of our polynomial. So step 1 is draw your parentheses and fill in using whatever variable we're going to use. Step 2, in the factor tree, or the chart that I was showing you earlier, we're going to use the first 2 columns to find multiples of our c value, our constant. So I want to find numbers that multiply to give me that constant. When I find some c values, or some values that multiply to give me c, I want to add them up and put their sum in the b column. So when I'm looking for numbers today, I want them to multiply to give me c and add to give me b. Number 3, we ask ourselves, what will the sign be in the parentheses? The signs in the parentheses will either both be positive, both be negative, or be different. One positive, one negative. And I'll show you how we get those when we get to our examples. Step 4, choose the correct multiple and signs and put in parentheses. And then step 5, check your work with double distribution, or as we called it previously, FOIL. We can always FOIL it out. And if we get back to our original polynomial, we know we factored it correctly. So I'll give you a little bit of time to write these steps down. All right, let's go ahead and move on. Here's an example with all the steps listed below it. If I were you guys, I would not write this example down, but just watch as I talk through the steps, and then write the next examples down whenever we're going over our examples. So the polynomial we're factoring here is x squared plus 4x plus 3. Step 1 said to draw your parentheses and fill in the correct variable. So we draw our 2 sets of parentheses. It's going to be our 2 factors. The variable is x, so x is going to be the first term in each binomial. Okay? Step 2, fill in multiples of your c value. What's our c value here? What's the c value here? The constant, the number without the variable.
3.
3. Yep. That's straight from the polynomial, right? What's my b value? 4. Here's my b value. Here's my c value. Everyone got that? B is always going to be multiplied by x. C is going to be the number without the variable. So, in the T chart, we list out things that multiply to give me 3. So does everyone agree that 1 times 3 gives me 3?
Yeah.
And negative 1 times negative 3 gives me 3? Are there any others, or is that it? That's it. Step 2 also tells me to add these across. What's 1 plus 3? 4. That's where I got this 4 from. What's negative 1 plus negative 3? That's where I got this negative 4 from. We want the two values that we pick to multiply to give me 3. So these values do multiply to give me 3. But we want them to add to give me positive 4. So which two values did both those things for me?
1 plus 3.
The 1 and the 3, right? So these are the values that I'm going to use in my factors. They multiply to give me the C value, add to give me the B value. That's how this T-chart helps us determine which numbers to use. Okay? So that was step 2, filling in the chart. Step 3 says, what will the two signs be in your parentheses? There's 2 ways I can determine that. I can look straight at my polynomial. If there's a plus sign in front of my C value, that tells me that my signs are going to be the same. So either both positive or both negative. Okay? If they're the same, the sign in front of the B value tells me what they'll be. So what are they both going to be here? Positive. Boom, boom. Another way I can determine that is what are the two signs of the numbers that I used over here that gave me the correct numbers? They're both positive, so I know I'm going to have both positives in the parentheses. That's 2 ways to determine the signs. Has everyone got that? So I put the plus signs in the parentheses. Step 4 tells me to fill in the correct numbers, the correct values, and the correct signs. So I just plug in the 1 and the 3. And this is factored form. That's where it's factored completely of my polynomial. Okay? Step 5 said to just check it using FOIL. I'm not going to expect you to FOIL out every single one on your assignment. Just kind of do it in your head real quick. Make sure that it FOILs out to become your original polynomial. And in this case it does. X times x, x squared. X times 3, 3x. 1 times x, 1x. 3x plus 1x gives me 4x. 1 times 3 gives me 3. Is that my original polynomial? Yes, so I know I have factored correctly. So the main thing, we want the numbers that we pick to multiply to give us C, add to give us B. Okay? Questions, comments, concerns on that? Can I move on to a lot more examples?
Sure.
We got lots of them.
So you're following.
Well, you don't have to write this down. These are what we call sum and product. The signs in the parentheses will either both be positive or both be negative for the ones we're about to go over. So, lots of examples here. Number 1. What does step 1 tell me to do?
Draw parentheses and fill in variable.
There's my parentheses. What's the variable I'm using? X. So I'm going to put X in the first slot of each parentheses. First term. Step 1 done. What does step 2 tell me to do?
In factor tree, use first 2 columns to find multiples of C and add them up in the B.
Yeah, so make your little T-chart. That's what we're calling our factor tree. What's my C value in this case? 4. What's my B value? 5. Whatever 2 numbers I pick, I want them to multiply to give me 4 and add to give me 5. Okay? So someone raise your hand and give me 2 numbers that multiply to give me 4. Raise your hand. Yes. 2 times 2. Everyone agrees that 2 times 2 equals 4. Okay, let's add them across. What's 2 plus 2? 4. So does 2 and 2 add to give me 4 and multiply, or reverse that? Do they multiply to give me 4 and add to give me 5? No. So that's not the pair I'm looking for. Yes, what's 2 other numbers that multiply to give me 4? 1 and 4. What's 1 plus 4? 5. Does 1 and 4 multiply to give me 4, add to give me 5?
Yes.
Yep, that's the pair I'm looking for. Okay? They meet my two conditions. They multiply to give me 4, add to give me 5. Does that make sense? Okay, that was step 2. Well, let me reiterate this. I used to have students list out all the factors of 4. So I had them put -2 and -2, -1 and -4. I used to have them list out every single combo that multiplies to give me 4. You don't have to do that. You can do what we just did here. Find two numbers that multiply, add them. If you get it on the first try, I'm good if you stop there. I do, however, want to see your T-chart every single time. Okay, that's you showing your work, in my opinion. I want to see your T-chart every time. Everyone got that? Okay. What does step 3 say? What will the signs be? What are our signs going to be here?
Positive.
Both of them?
Yeah.
Yep, both positive. Once again, if the sign in front of C is a plus, I know they're going to be the same. If I know they're the same, the sign in front of B will tell me what they're both going to be. They're both going to be plus. Also, the two numbers that we're using are both positive, so I know I'm going to have two positives in my parentheses. We good with that? Step 4.
Choose the correct multiple signs and
Yep. Choose the correct multiples. So we've already chosen them. We just got to fill them into our principles. Parentheses. 1 and 4. Now, since these have the same signs, does it matter where I put the numbers? No, I can put them in either parentheses. If I have x plus 4 times x plus 1, that's the same thing. And there's my answer. That's factored form of our polynomial.
Okay.
Any questions about that? Are we good with that?
Sure.
Okay. Can I erase my chart and move on and move a little faster?
Yeah.
All right. Number 2. What's my variable?
X.
X. Let's fill in our T chart over here. What's my C value? 10. B value? 7. Raise your hand if you can give me two numbers that multiply to give me 10.
Oh, 5 and 2.
5 and 2. What's 5 plus 2?
7.
7. Do our two numbers multiply to give me 10 and add to give me 7?
Yes.
Yes, they do. Those are the two numbers that I want. I'm done. I got it on the first try. What are the signs in parentheses going to be? Both positive. And then, what do you want in the first parenthesis? Which number?
5.
5. Second.
7.
2.
2.
If you put x plus 2 times x plus 5, that's the same thing. There's my answer. Questions on 2? How are we feeling about this? We got a lot more to cover. Can I skip to 4 here?
Sure.
What's my variable?
X.
X. What's my C value? 36. B value? 13. Raise your hand if you can give me two numbers that multiply to give me 36. 13 and 2. What's 13 plus 2?
Take that back.
What's 13 plus, or 13 times 2? 26. So that will not work. What did we say?
6 and 6.
6 times 6 does give me 36. What's 6 plus 6?
12.
12. Is that what I want? No. I want it to multiply to 36, add to 13. Raise your hand if you can give me another combo that multiplies to 36. 4 times 9. What's 4 plus 9? 13. Do those two numbers multiply to 36? Add to 13? Yes, they do. There's the combo that I want. 4 and 9. What are my signs going to be in the parentheses? Both positive. Everyone good how we're getting the two signs?
Yeah.
And then what are my numbers? 4 and 9. Questions on 4. X plus 4 times x plus 9. Those are my two factors. We good with that?
Sure.
Do I need to do number 5?
No.
I Can if I need to.
No.
No?
No.
Feeling good about it?
Yes. Sure. Yeah.
Can I move on?
Yeah.
To me, you're about to be real mad at me. Here we go. More examples. Number 6. What's our variables? X. What's my C value? 100. What's my B value?
29.
Not 29. Ooh, that's a little different. Negative 29. Raise your hand if you can give me two numbers that multiply to 100. Raise your hand. Yeah.
10 plus 10.
10 times 10?
10 times 10.
10 times 10 does give me 100. What's 10 plus 10? What?
20.
Positive 20. Is that what I want? No. That's not the combo I'm looking for. Yes?
Negative 25 and negative 4.
Negative 25, negative 4. Does that multiply to 100?
Yes.
Yeah. What's negative 25 plus negative 4?
Negative 20.
Negative 29. Is that the combo I want?
Yeah.
Yes, it is. They multiply to 100, add to negative 29, so those are the two numbers that I want. What are my signs going to be?
Negatives.
Both negatives?
Yes.
Very good. They are both negatives. Once again, if I've got a plus sign in front of C, it tells me my signs are going to be the same. If I know they're the same, the sign in front of B will tell me what they'll both be. Also, the two numbers that I'm using over here are both negative, so I know I need two minus signs. Everyone got that? Okay, fill in our numbers. Here's our factored form of our polynomial. Questions on 6?
No.
Still feeling good?
Yes. Sure.
Can I skip to 8?
Sure.
Yeah.
Yes.
No? I need to do 7?
No.
I can do 7 if I need to.
No.
Okay.
No.
Skip to 8. What are my variables?
X.
X. C value. 24. B value.
Negative 14.
Negative 14. Raise your hand if you can give me two numbers that multiply to positive 24. Raise your hand.
I'm trying to think of what it actually is.
Just give me two that multiply to 24.
6 and 4.
6 and 4. What's 6 plus 4?
24. I mean.
10. Is that the combo I'm looking for?
No.
No. Raise your hand if you can give me another combo.
Negative 12 and negative 2.
Negative 12 and negative 2. Those do multiply to give me 24. What's negative 12 plus negative 2?
Negative 14.
Negative 14. Is that the combo I'm looking for?
Yeah.
Yes, it is. They multiply to positive 24, add to negative 14. That's what I'm looking for. What are the two signs going to be?
Negative.
Negative
12 and 2.
12 and 2. Or, since they have the same sign, if I put x minus 2 times x minus 12, that would be fine as well. Okay? Questions on 8?
No.
Can I skip to 10?
Yes.
Yar.
We getting the hang of it? Hopefully. What's our variable? X. What's my C value?
25.
25. B value?
Negative 10.
Negative 10. I want two values that multiply to positive 25, add to negative 10. Raise your hand if you can give me two values that multiply to 25. Raise your hand. Yeah.
5 times 5.
5 times 5 does give me 25. What's 5 plus 5?
10.
10. Is that the combo I want? No. It's close. Yeah.
Negative 5 and negative 5.
Negative 5 and negative 5. Those do multiply to positive 25. What's negative 5 plus negative 5?
10.
Negative 10.
Negative 10.
Is that the combo I want?
No.
Yes, it is. What are my two signs going to be in the parentheses?
Negative.
Both negative. We okay getting the sign still?
Yar.
And then they're both 5. There is another way I can write this, which is the way I would prefer you write it. Anyone raise your hand and tell me how I can rewrite this? Yeah. X minus 5 squared.
You want to write like
I want you to write it like that, yeah. If you got two of the same binomial being multiplied together, just write it as x minus 5 squared. Or whatever the binomial is squared. Questions on that?
No.
We're good. We're still going. We still got more. Don't write this down. Just pay attention to it. The previous slides, we dealt with polynomials that we call sum and product. Those polynomials were one of the following forms. We only saw these two forms, correct? If they were a plus and plus, they were two plus signs in our parentheses. If they were minus plus, they were two minus signs in our parentheses. That's all we dealt with so far, correct? Next slide, we're going to look at polynomials that we call difference in products. These polynomials will be one of the following forms. In the polynomial, it'll be a plus and a minus, or a minus and a minus. If we have a minus sign in front of our c value, that just tells us that our signs are going to be different in the parentheses. Okay? So plus sign in front of c told me they were going to be the same, so I had to look in front of b to see what they were going to be. Right? If there's a minus sign in front of c, I automatically know they're going to be different every time. So I don't even have to look at b's sign at that point. We good with that?
Yeah.
All right. More examples. Here we go. Same process though. We're still looking for two numbers to multiply to give us c, add to give us b. So number one,
X.
what's my my variable?
X.
X. What is my c value? Negative 24. B value,
2.
positive 2. Raise your hand if you can give me two values that multiply to negative 24.
Negative
Raise your
12.
hand.
Are you there?
Yes. Negative 12 and that'd give me a positive if I multiply them. Negative 12 and positive 2 would multiply to give me negative 24. What's negative 12 plus 2? Negative 10. Is that the combo I want?
No.
Nope. That's okay. Yes.
6 and negative 4.
6 times negative 4 does give me negative 24. What's 6 plus negative 4?
2.
2. Is that the combo we want?
Yard.
Yep. They multiply to negative 24. Add to give me positive 2. That's the combo. What are my signs going to be?
Positive and negative.
One's a plus, one's a minus. Does it matter where I put the plus and minus?
No.
No, I could put the minus first if I want, and then the plus second. Once again, there's two ways to determine that. I've got a minus sign in front of my c value. That automatically tells me I'm going to have different signs. Also, the two values that are my correct combo, one's a positive, one's a negative, I know I'm going to have different signs. Does it matter where I put the 6 and the 4?
Yes. 6 and then 4.
In this case, it does matter since they're different signs. I've got to make sure the correct number goes with the correct sign. So my positive number, 6, needs to go with the plus sign. My negative number, 4, needs to go with the minus sign. So in this case, it does matter where the numbers go. They have to have the correct sign with them. Questions on 1? We good with that? Can I skip to 3? Sweet. Okay, what's my variable here? N. What's my C value?
Negative 24.
Negative 24. B value? Negative 5. Raise your hand if you can give me two numbers that multiply to give me negative 24. Raise your hand.
Negative 12 times 2.
Negative 12 times 2 does give me negative 24. What's negative 12 plus 2?
Negative 10.
Negative 10. Is that the combo I want? No. Yes.
8 times negative 3.
8 and negative 3. Those do multiply to give me negative 24. What's 8 plus negative 3?
5.
5. Is that the combo I want?
No.
Not quite. We're pretty close. Someone else raise your hand and give me another combo.
Negative 8 times 3.
Negative 8 and 3 does give me negative 24. What's negative 8 plus 3?
Negative 5.
Negative 5. Is that the combo?
Yes.
That is the combo that I want. What are my signs going to be in the parentheses?
Positive.
Negative. I mean, yeah. Negative.
Negative and then
plus
positive.
They're going to be different, right? So a positive and a negative. Where do you guys want the positive, first or second?
First.
First, you want the negative second. So I get n plus what?
Negative 8.
3
Oh, shoot.
n minus
8.
8.
That's because I be moving too fast. I was just like,
Make sure you get the correct number with the correct sign. Everyone got it?
Yar.
Questions on 3? Can I skip to 5?
Yar.
It's my variable.
Why?
Y. C value.
Negative 16.
Thank you. Yeah, it looks pretty good, huh?
Negative 6.
Negative 6 is my B value. Thank you. Raise your hand if you can give me two values that multiply to give me negative 16. Raise your hand. Negative 8, positive 2. That does multiply to give me negative 16. What's negative 8 plus 2?
Negative 6.
Negative 6. Is that the combo I want?
Yes.
Yes, it is. What do you want in the first parenthesis, plus or minus? Minus. So that means plus will go in the second. So I get y minus 8 because it's my negative 8. Y plus 2 because that's my positive 2. How are we feeling about factoring?
So amazing.
Amazing. Okay. Okay, at least.
Can we be done now?
Questions on it? There's more. Remember, we got to talk about difference of squares as well. We haven't done that yet. Any questions on factoring polynomials in the form we just did?
No.
Okay, now let's talk about difference of squares. So, a difference of squares is where it's two-termed polynomial. They have a minus sign between them. That's why it's called the difference of squares. And my two terms are perfect squares, meaning I can take the square root of them. So I would write these steps down if I were you. Steps to factoring a difference of squares polynomial. First, we need to make sure you have an actual difference of squares. It must be subtraction sign, and you can square root both terms. If it's not a subtraction sign and I can't square root both terms, it's not a difference of squares. I cannot factor it using this method. Step 2, use the following rule to factor. You definitely need to have this rule written down. A squared minus b squared, which is the form that our polynomial will be in, equals a plus b times a minus b. I get my a value from taking the square root of a squared, my first term of my polynomial. I get the b value from taking the square root of the second term. Okay? And then one sign's a plus sign, the other sign's a minus sign. And then you can always check your work using FOIL. Yeah?
Do not write the word too.
I would recommend it, but you probably don't have enough time at this point because I'm about to be moving on. At least make sure you get that rule written down. Okay? Are there any questions about it
No.
before we get into it? Here's some examples. Number 1, n squared minus 64. So let's first make sure it is a difference of squares. It's got two terms. Is it a subtraction problem?
Yes.
Yes, so there's the difference part. Can I take the square root of my first term? N squared? Yep. Can I take the square root of 64?
Yes.
Yep. So, this is a difference of squares. Okay? So I can follow this rule. Okay? So I'm going to go ahead and draw my parentheses. To get my a value for each set of parentheses, I take the square root of my first term. What's the square root of n squared? Let's see if we remember this. N. When I'm taking the square root of something, I'm asking myself what number or variable times itself gives me that value. So n times itself would give me n squared, right?
Yeah.
So the square root of n squared is just n. Does that help make a little more sense?
Yeah.
Hopefully. Okay. Square root of 64.
A
8. That's how I get my b value for each set of parentheses. And then based on my rule over here, one's a plus sign, one's a minus sign. There's factored form.
Are we done?
It's always gonna be like that?
If you have a difference of squares, yes. That's it.
Are we done with that?
Yeah, we're done with number 1. If you FOIL it out, what's n times n? N squared. What's n times negative 8?
Negative 60.
Negative 8n. What's 8 times n?
8 times n.
8n. What's 8 times negative 8? Negative 64. What happens to those two middle terms?
It gets combined.
Boom, boom, they cancel out. Right? So what are we left with? Which is my original polynomial, so I have factored correctly. Okay? We okay with that? Number 2. Is this a difference of squares?
Yes.
Let's go through the steps here. Is it a minus sign? Yep. Can I take the square root of 1? Yeah. I can take the square root of 1.
Oh, what?
Yeah. Can I take the square root of 49y squared?
Yes.
Yes, I can. So let's draw our parentheses here. What's the square root of 1? 1. There's my a value for each set of parentheses. What's the square root of 49y squared? Say it again. 7.
7.
Why?
Just 7y.
My fault.
Just 7y. If I do 7y times 7y, I'll get back 49y squared. Everyone got that? And then one's a plus, one's a minus. There's my answer. We good with that? Questions on it?
Nope.
Okay, number 3. Just going to tell you, this is all these are difference of squares. Okay? They are all subtraction problems, and I can take the square root of each of my terms. Until we get to number 5, but we'll talk about that when we get there. Dun, dun, dun. Okay, number 3. What's the square root of 64u squared?
8.
8.
8.
8u.
2. Oh,
8u.
wait. Oh, okay.
We're on 3. I'm sorry.
My bad.
It does kind of look like we're on number 4. Sorry. What's the square root of v squared? V? 1v or just v? It's the same thing, right? One's a plus, one's a minus. There's my answer. Questions on 3?
No.
Nard.
You're just not getting on to that?
No. Nar. Sorry. Square root of 64m to the 4th. Ooh, this one's a little different. I heard it. 8m squared. If I multiply 8m squared times 8m squared, I would get 64m to the 4th. Everyone got that? What's the square root of 9n squared? 3n.
Y'all, my God.
One's a plus, one's a minus. How are you feeling about difference of squares?
It's
easy.
It's alright. Alright. Questions on 1 through 4 up to this point?
No.
Okay. Can I erase these 4 to give myself more room for number 5? No, it's not bad. It's not bad. But I just wrote really big for 1 through 4.
I need a new paper.
Good.
I'm about to fill up too. Is there a lot more left?
No, we're getting close.
I'm about to get my third page.
Okay. 18x squared minus 50. Can I take the square root of each of my terms?
No.
Yeah.
I can?
Oh, no, because 18.
No, I can't take the square root of 18 or 50, can I?
Oh, no.
Does anyone see anything I could do before I do anything else?
Make them
Do the
squares.
little thing where you like take
How?
out a number.
You can take, yeah, you can cross factorize it.
Factor out a
What is, oh, wait.
G, C, F. Yeah. So, I do want us to get in the habit. I should have been doing it on all the examples we did today. always look for a GCF before you start factoring anything. Okay? I kicking myself for that one. I should have had y'all check. None of them have had a GCF up to this point for the whole polynomial. But number 5 does. What's the biggest number that goes into 18 and 50? 2. Do they have any x's in common? No. So 2 is my GCF here. 2 times what would give me 18x squared? 9x squared. 2 times what would give me negative 50? Negative 25. Everyone okay with how I got my factored out my GCF? No, that's not it. Because now, what do I have in my parentheses?
You have a square root.
I got a difference of squares. So I can factor this further by factoring my difference of squares now. Okay? Now, be careful here. 2 does need to be a part of your answer because I factored that out. It's just going to sit out there in front of all my parentheses. Okay? I'm going to have to put it up here. Well, that didn't give me any more room. So I'm going to draw my 2 sets of parentheses with 2 in front of them. So what's the square root of 9x squared? 3x. Square root of 25? 5. One's a plus, one's a minus. So 2 times 3x plus 5 times 3x minus 5 would be my factored form of my polynomial. That's my answer, yep. So, all we really added to it was checking for a GCF before we do the difference of squares. Okay? We good with that? Okay, I got 3 more examples for you, then I'm done. Okay, that's it. Last 3 examples here.
We have 7.
Number 6, 80 into the 4th minus 125 n squared. Do you think the rest of these are probably going to have a GCF?
Yes.
Probably, yeah. So, what's the biggest number that goes into 80 and 125? 5. How many n's do these 2 terms have in common? 2. So 5n squared is my GCF that I can factor out before I do anything else. 5 times what gives me 80? 16. I'm distributing 2 n's in, but I've got 4 here, so how many more do I need to get from 2 to 4? 2 more. So 16n squared is the first term in the parentheses. 5 times what gives me negative 125? Negative 25. Do I need any more n's for this term? No. Now, do I have a difference of squares in my parentheses? Yes. There's a subtraction sign. I can take the square root of my first term and my second term. Once again, that 5n squared is going to be a part of our answer. So you need to bring it down and put it in front of your parentheses. What's the square root of 16n squared?
4n.
4n. Square root of 25? 5. One's a plus, one's a minus. Questions on 6? Still feeling okay about difference of squares? Just always look for a GCF before you do anything. Okay? Biggest number that goes into 8 and 32? 8. Do we have any x's in common? No. Do we have any y's in common? How many? Just 1. 8y is my GCF. Everyone good with that? 8 times what gives me 8? 1. How many x's do I need for this first term? So x squared. Do I need any more y's? No. 8 times what gives me negative 32? Negative 4. How many more? Do I need any x's? No. Do I need any y's? How many? 2. We good with that? Do I have a difference of squares in the parentheses? Yes, I do. Once again, 8y has to be a part of my answer. Square root of x squared?
X.
x square root of 4y squared,
Negative 4y. Oh, 2y. My
2y. One's a plus, one's a minus. Questions on 7.
No.
And last but not least, number 8. Do I have a GCF here?
Oh,
One.
no.
Yeah,
Yeah.
1's the biggest number that goes into those coefficients because those are 1. How many m's do we have in common? 1 m. How many n's do we have in common? 1. So mn is my GCF.
Ooh.
For the first term, how many more m's do I need?
3.
One more.
2.
Oh, 2?
Because I got to get from 1 to 3, right? So 2 more m's. Do I need any more n's?
No.
No. Do I need any more m's for the second term?
No.
No. What about any n's?
No.
So I just have a minus 1. Do I have a difference of squares? Yes. Square root of m squared. M square root of 1. 1's a plus, 1's a minus. Questions on that?
No.
So, always check for a GCF, and then you can do your factoring. Okay? Difference of squares, take the square root of the first term, square root of the second term. 1's a plus, 1's a minus. Questions, comments, concerns about any of the notes we just took?
No.
No, we'll get the assignment on Monday.